Alright friends, in this question we are given a long solenoid of diameter 0.1 meter has 2 into 10 to the power 4 turns per meter. Okay, so we are given a solenoid, its diameter is mentioned and number of turns per unit length is given. At the center of the solenoid there is a coil of 100 turns, number of turns are given in the coil, radius is given 0.01 meter, is placed with its axis coinciding with the solenoid axis. Alright, so that means the magnetic field of this long solenoid, if it carries current, will be normal to the area of cross section of this coil which is at the center. This current in the solenoid reduces at constant rate, okay, from to 0 ampere from 4 ampere in 0.0105 seconds. So we are also given the change in current in the solenoid and the time interval in which the change in current takes place. Resistance of the coil is given to us as 10 pi square ohm. The total charge flowing through the coil during this time is, well, the direct formula for calculating the charge flown as a result of induced EMF is change in flux divided by resistance. The flux phi1 minus phi2 divided by R. Now flux, if we see, final flux will be 0 because there is no current in the solenoid, and initial flux is what we'll have to fill here. So that will be number of turns into magnetic field into area of cross section into cosine 0, which would be 1 eventually. So N is number of turns of the inner coil, B is magnetic field due to solenoid, area A is the area of cross section of the inner coil. So we fill the values, N into mu naught Ni. Here small n is the number of turns per unit length of the long solenoid, I is current in the long solenoid, and pi r square, R is the radius of the inner coil. So divided by R, capital R, which is the resistance of the inner coil. Now we fill in the values whatever are given. First we write down the formula, that is mu naught pi n small n into capital N into r square into I by r, that is after rearranging this. Now we fill in the values. Mu naught can be written as 4 pi into 10 to the power minus 7. Then pi will keep it as such here. Small n is number of turns per unit length, which is 2 into 10 to the power 4. We write down like that, and then capital N is 100, so we fill that value here. Pi we have kept as such. R square, R radius of the inner coil is 0.1 meter, 0.01 meter, and then we have to square it, so this is 10 to the power minus 2, and then we square it as well, and then multiplied by current, which is the initial current, that is 4 ampere. We fill that 4 here. The interval of time is of no use, no significance in calculations, divided by capital R, that is resistance of the inner coil, given to us as 10 pi square. Having filled all the values, we see that pi square gets cancelled, and then after rearranging, the final answer comes out to be 32 microcoulomb. This is the charge which is moved due to induced EMF, which is given to us in option 2. Correct answer to this question hence is option 2.